this is Nablo Tutoring, and just a quick announcement, because we did not upload a video last week, we are going to be uploading 2 videos this week, so stay tuned for that, and we will get right into the video.
Welcome back, everyone. Today we're going to talk about how to use the Pythagorean Theorem in cubes and rectangular prisms. Now, before we start, it's really important you've watched our previous 2 videos in the Pythagorean Theorem so that you properly understand and are able to follow along. Now, we're going to use the Pythagorean Theorem to find the diagonal in cubes and rectangular prisms. Now, the diagonal of a cube is the segment that cuts through the cube in half. So this line that goes through from point A to point B, and it can also go from this point to this point. Those 2 lines would have the same length, and they're both considered as the main diagonals of the cube. Now, you may be wondering, how are we going to find this diagonal using the Pythagorean theorem? Now, first, let's give the cube a width of 3. And since it is a cube, it means that all these sides, this one right here, that one right there, that one, it's going to have the same length. So all are going to be 3. So now that we know that, let's get started. Now let's note up here the formula, which is a squared plus b squared, a squared plus b squared equals c squared. Now, how I like to do this is you first divide the base of the cube into 2 right triangles. This is going to be a right angle that these 2 sides form. Now, as you can see, we already have 2 triangles right over here and another one right here. And we can use the Pythagorean theorem to find this side, the hypotenuse of this second triangle that we made over here. But before, we have to find this side and this side in order to find that one. Now, we already know what this side is since it is the height of the cube, and it's going to be 3. Now, we have to find out what this side is as well. And this side over here is also going to be 3 since it is a cube. And now we have a right triangle over here, right here. That's one of the 2 triangles we created when we split the base in half. Now let me map this out onto the side to make it a bit more clear. Now, I'm sorry this is not to scale, but it's just an example. So this side right here is going to be this one. So it's going to be 3. This one's also going to have a length of 3. And now we're going to solve for C. So let's go ahead and do that down here. So C is the hypotenuse since it is the side opposite to the right triangle. So we would have 3 squared, which is A, plus 3 squared, which is B, equals C squared. Now, let's simplify this and we get 9 plus 9 is equal to C squared. We add 9 plus 9, and we will get that 18 is equal to C squared. Now, let's take the positive root of both sides, and we would end up with C being equal to the square root of 18. So now we know that this side over here is the square root of 18. So now, think about it. Now we know the height of this triangle. We know its base. So we know already 2 sides. So we can just apply the Pythagorean theorem in order to solve for the hypotenuse of this right triangle, which is also the diagonal of the cube. So let's go ahead and do that down here. So we would have 3 squared plus the square root of 18 squared, since it is this side right here and this side right here, the 2 smaller sides, being equal to C squared. Now let's simplify this and we get 9 plus 18 equals C squared. We add these 2 and we will get that 27 equals C squared. take the positive root of both sides, and we would end up with c being equal to the square root of 27. So now we know that the diagonal of this cube is equal to the square root of 27. Okay, so here we have another example, and notice instead of this being a cube, it is now a rectangular prism, and not all the side lengths are going to be the same. But we're going to use the same idea to find this side right here, which is the diagonal of this rectangular prism. So once again, I'm going to start by splitting the base in half, getting two right triangles. One over here, and this would be its right angle, and another one over here, and this would be its right angle. Now, in order to find the diagonal of this rectangular prism, we would have to know two sides of this triangle we just created by splitting the base in half. We already know one of them, which is 10 right over here, and we're going to now find this one using this right triangle we created. So let me go ahead and do this to the side so that it's more clear. So we just created this right triangle, and it has this side length. This one right here is going to be 15. This one is going to be 6. And now we're going to solve for C, which is the hypotenuse since it is the longest side opposite to the right angle. So now let's use the formula here to solve for it. So we would have 15 squared plus 6 squared is equal to C squared. Now the 15 squared is 225 plus 36, which is 6 squared, equals C squared. Now we're going to add these two. We're going to add them to simplify, and we will get that 261 is equal to C squared. Now we're going to take the positive root of both sides and get that C is equal to the square root of 261. So now we know that this side right here is equal to the square root of 261. So now that we know two side lengths of this triangle, the one we created to find the diagonal, now that we know two side lengths, we can always find the third one. So let's go ahead and do that over to the side here. So let me draw this for you. So the height of this rectangular prism is 10. So it would be this side right here. This side would be 10. Now the side that we just solved for right here is the square root of 261. So this is going to be the square root of 261. Now once again, let's use a Pythagorean theorem over here. So the square root of 261 squared plus 10 squared is equal to C squared. Now let's simplify this, and we will get that 261 plus 10 squared, which is 100, equals C squared. Let's combine like terms, so we would add those two and get that 361 equals C squared. We're going to take the positive root of both sides. Now the positive root is going to cancel out the exponent, so we will be left with C is equal to the square root of 361, which is in fact the perfect square of 19. So we would have that C is equal to 19. So therefore, the diagonal of this rectangular prism is equal to 19. Now hopefully it makes sense now. That is how you would use the Pythagorean theorem to find the diagonal of cubes and rectangular prisms. Thank you so much for watching. Like and subscribe, and see you next week.